Imagine flying through complete darkness. No moon, no stars, no light at all. Now imagine chasing tiny insects at high speed without crashing into trees. That's exactly what bats do every night. So how do they see in the dark? They don't use their eyes. They use sound. This is called echolocation, and it's one of the most extraordinary biological abilities on Earth. First, let's clear up a myth. Bats are not blind. Most bats can see, but in darkness, vision becomes unreliable, so instead of depending on light, bats create their own sensory system. Here's how it works. A bat produces extremely high-frequency sounds, so high that humans can't hear them. These are called ultrasonic calls. The sounds shoot out into the environment, hit objects, and bounce back as echoes. The bat listens to those echoes. From the returning sound alone, it can calculate distance, size, shape, speed, even texture in real time. Think of it like biological sonar, but far more precise than most human technology. When a bat emits a call, it might last only a few milliseconds, but the returning echo carries massive information. If the echo comes back quickly, the object is close. If it takes longer, the object is farther away. The delay between sound and echo tells the bat exact distance. Now here's where it gets even more impressive. As a bat approaches an insect, it increases the rate of its calls. This is called the feeding buzz. At that moment, it can emit up to 200 calls per second. That allows extreme accuracy just before capture. It's like switching from normal camera mode to ultra slow motion tracking. But how detailed is this sound vision? Studies show bats can detect objects as thin as a human hair. They can distinguish between different insect species. Some bats can even sense the fluttering of insect wings based on tiny shifts in sound frequency. That shift is called the Doppler effect. If the insect is moving toward the bat, the echo's pitch changes slightly. If it moves away, the pitch shifts again. Bats detect those changes instantly. To them, the world isn't dark. It's a detailed 3D sound map. Now let's talk about their ears. Bat ears are not just for hearing. They're precision sound receivers. Their ear shapes help funnel echoes efficiently. Many species can move their ears independently, fine-tuning exactly where the echo is coming from. And their brains? Incredible. A large portion of a bat's brain is dedicated to processing sound. Their auditory cortex is highly specialized to interpret echo timing and frequency shifts with extreme speed. In simple terms, they don't just hear sound, they translate it into space. And it doesn't stop there. Some bats adjust the frequency of their calls to avoid interference from other bats nearby. Imagine thousands of bats flying together at night, each one emitting sound, yet they don't get confused. They slightly shift frequencies to separate their signals, like tuning to a different radio station. So what does the world look like to a bat? It's not a visual image like ours. It's more like a constantly updating, high-resolution, three-dimensional sound landscape. Trees are shapes of echo, insects are moving pulses, walls are solid sound barriers. They fly through darkness with precision that rivals vision, all by listening. Echolocation isn't just fascinating biology, it has inspired human technology. Submarines use sonar, doctors use ultrasound imaging, engineers study bat navigation to improve robotics and drones. Nature perfected it millions of years ago, so next time you see a bat at night, remember this. It's not blindly flying, it's scanning, mapping, calculating, turning sound into sight, and navigating a world most of us would never survive in.